Hey everyone, we're going to look at number 21 in section 5.4. We're going to write the integral that is given as a sum of integrals without absolute values. So without absolute values. Um, and then we're going to evaluate. So you have to rewrite this without absolute values. So some of you I know can use your calculator to evaluate this. That's fine, but that would not be credit for this problem. You have to show the integral as a sum of integrals without the absolute values. So let's think about this from integrating -2 to 6 of the absolute value function. Here's the graph in red of the absolute value function. And basically what's happening is if x is greater than or equal to 0, then the graph of the function is just equal to x, right? If I've taken the absolute value of any positive number, I get that number. But what happens if x is less than 0? Okay, well, what if x is -3? The absolute value of -3 is +3. Absolute value of -2 is +2. So one way of thinking about that is we're basically multiplying by -1, right? If I multiply -3 by -1, I get +3. Multiply -2 by -1, I get +2. All right, and that's how we're getting these values above the x-axis there. So it's really can be thought of as a piecewise defined function this way. Another way of thinking about it, this is the graph. If I continue this way, this is the graph of the function y equal x, right? Y equal x. And notice for values of x greater than or equal to 0, y equal x is equal to the absolute value of x. But for values less than -x, all right, less than 0, less than 0, then the graph is just a reflection in the x-axis, right, of the absolute value of x. So I've got to, how do we do that? Well, just multiply by -1, right? So the negative x will pop this up here. And we're integrating from -2 to 6. So we want to get, these two areas. And so to correctly do this, we're going to break this integral up into two. From -2 to 0, right? What are we going to integrate? -x, because the values of x are less than 0, so that we're actually integrating under this curve, not here, right? If we just integrate x, we would be accumulating negative area. And then we're going to go from 0 to 6. Well, that's just going to be integrating x, right? Because that's the same function if x is positive and all our values are positive. So this is the way you have to write it as a sum of two integrals in this case without absolute value. Now we can integrate both of these very easily using the fundamental theorem of calculus. The antiderivative of -x is -1/2 x squared. Going to evaluate that at the upper limit of 0 and the lower limit of -2. So if I plug in 0, I get 0. And if I plug in -2, I get +4 times -1/2 is -2. So 0 minus -2 is 2. And very similar over here, the antiderivative of x is 1/2 x squared. Evaluated at 6, evaluated at 0, subtract, and I get 18. So the net, this first integral is 2, and the second integral is 18. So the total value of this definite integral is 20. And notice the first integral here, the 2, that represents the area here that I've shaded in between -2 and 0. And the 18 represents the area from 0 to 6 under here. In fact, geometrically, you can see these are just triangles, and you can find the areas of both of these triangles. The area of this triangle is 2, the area of this triangle is 18. So that all is making sense, hopefully, on this one, and I hope this is helpful.